In progress.
So actually it is sigma by 2 epsilon naught. So it is 2 sigma by epsilon naught minus k. Then you go ahead to 25th. An infinite line charge produces a field of the distance 2 cm. Linear charge density is this formula goes infinite line charge lambda by 2 pi epsilon naught r equal to electric field. So S is given. This is the asked line charge density. Epsilon naught you know 4 pi 1 by 4 pi epsilon naught is 9 to 10 power 9. So accordingly we will be there. And distance is given 2 centimeter. We take okay. Anyway, it is in per centimeter. Okay. We can do this. Then here this again. English 6. In many situations, to find the electric field using the Gauss law, we can use the simplified equation. Okay, A is area. Okay. Among the following situations, this equation can be used. Okay. So Gauss law is integral E dot dA is equal to Q enclosed divided by epsilon. So now they are able to just write it as EA. This part they are able to write it as E into A. How this is possible? First of all, E dot dA can be written. E bar dot dA can be written EDA. And that will happen when theta is 0 degree. Cos 0 is 1. So theta should be 0. Then EDA, then E should be same everywhere so that it will come out. So E should be constant. And integral dA is taken as only A. So these two should happen. When it will happen only when Gaussian surface is an equipotential surface. So equipotential surface means at every point potential is same. Second means only when E is constant on the surface. So E should be constant. Yeah, it is correct. Only when Gaussian surface is an equipotential surface and E is constant of the okay. See, angle between E bar and A bar will be should be 0. Means if this is a surface, A bar will be perpendicular to the surface, E should also be perpendicular. Right? So if E bar is perpendicular, it means E bar doesn't have any component along the surface. And that means it is Gaussian surface. So both are correct. So Gaussian surface is equipotential surface. Then 27th. An electric dipole is placed in a uniform electric field. A dipole will experience. Okay. So if this is uniform, so force will not be there. Only torque will be there. Right. Force will not be there. So only torque will be there without displacement because there is no force in it. This one is C. Then 28th. An uniform electric field E exists along positive x-axis. The work done in moving a charge 5 coulomb through a distance of 2 meters along the direction making an angle of 60 degree. The x-axis. So this is the x-axis. Electric field is along the x-axis. Charge is there. It has to be moved through a distance of 2 meters along the direction of making an angle 60 degree with x-axis. So 60 degree with x-axis. This direction you have to move it is 10 joule in the magnitude of electric. So work done is 10 joules. So work done is force into displacement. So force is given to E. Charge is 0.5. E we want to know QE. QE force is in this direction, but we want only this component. Cos theta. So cos 60 is 1 by 2. Displacement along the direction is 2 meter. So this will be 10. This two cancels. E is 20. 2 and 2. Then 29th. Which one of the following represents variation of electric field with distance r from the center of spherical conductor of radius r? So it is conductor. So charge will just come here above on the surface. And electric field inside becomes 0. And at the surface it will be maximum, then it will go on the period. So where it is 0, here it is 0. Then it will become. So it's option C. Then 30th, a hollow cylinder is there, okay, has a charge q coulomb within it, okay. Q coulomb is there. If phi is the electric flux in units of voltmeter associated with the curved surface, okay, B is flux phi. The flux linked with plane surface A, okay, only A in units of volt. See, flux through this and this plus this whole will be the net flux, and net flux is q inside by epsilon naught. So net flux will be phi plus flux through this, and this will be same actually due to symmetry. You take it as 2x. We want x actually, so take it this side, q by epsilon naught minus 5 and by 2. Then 31. Option D. E be the electric field strength for short dipole and on its axial line, and E on equatorial plane the same distance. Okay. Electric field, axial electric field is K into 2p by r cube. Equatorial it is K into p by r cube. So R is same there telling. K also same. So one is 2p, one is p. E is p. So and EA is 2p. So EA will be equal to 2E. So it will be option B. Right? 31 will be option B. And 32. Charges of equal value Q are placed at vertices of an equilateral triangle. The resulting lines of force should be sketched as seen as in. Okay. U here if you see, so you see inside it should be 0, right? Then here it is 0. Here if you see, here some electric field is there, so it's there. Here also if you see is little bit electric field inside, and here you see is some electric field here which is not correct. So it is option C. 33. 3 point charges Q1, Q2, Q3 in the order are placed equally spaced along a straight line. Okay. equally spaced. Q2 and Q3 are equal in magnitude but opposite in sign. So Q minus Q. The net force on Q3 is 0. The net force on this is 0. The value of Q1 is okay. So this will attract, so this should repel. So it should be, so both should be equal in magnitude. So K Q by, so this is R, so K Q by R square, and one more Q will be there. And for this it will be K Q1 into Q, the force on this, by this will be 2R because equally spaced, no? So it will be 2R, 4R square. This cancel, 1Q cancel, sorry Q1, Q cancel. So Q1 will be equal to 4Q. Q1 will be 4 Q3 or Q2. 34th. Electric charge is uniformly distributed along a straight line wire of radius 1 mm. Charge per centimeter length of the wire is Q coulomb. So another cylinder of radius 50 centimeter and length 1 meter symmetrically encloses the wire. Okay, so there is some cylinder. Inside that this is there, uniformly distributed. The total electric flux passing through the cylindrical surface is, okay, so it will be Q inside by some not. So Q inside is how much? It's 1 meter. So 1 meter length we have. 1 centimeter has Q charge. So 1 meter will have 100 centimeters. So 100 Q. So Q inside is 100 Q by epsilon naught. What is the option? Yeah, B. Okay. 35. A small sphere carrying a charge Q is hanging in between two parallel plates by a string of length L, time period of pendulum is T0. When parallel plates are charged, the time period changes to till T. The ratio is so. So when they are not charged, only G was there. So T0 was 2 pi root of L by G. So T0 was related to G and T is related to it is charged, no? Okay. Which carries charge and they are charged. This will repel, this will attract. So QE by M will be down at acceleration. So G plus QE by M. So T by T0 will be Down it will be G by QE plus M, QE by M, and above it will be G whole power 1 by 2. 35 will be C. Then 36. An electric dipole consisting of two opposite charges of E separated distance is given, this is given, electric field is given, torque they are asking. So tau is equal to P sin theta. Theta is not given. You take it as 90. P into E, distance is given, charge is given, electric field is given. Right? Solve it. Then 37th, electric field in a certain direction is acting radially outward and is given by AR. A charge contained inside a sphere of radius A centered at the origin will be given by so it is this radius is A. The charge is how much they are asking, right? So charge will be Q inside by epsilon naught is E into A, E dot dA, right? Integral. This they are asking, so it will be E dot dA. E is AR and dA. So area. So flux. How much will be flux? So everywhere AR will be same only at every point here where you want flux. So it will come out integral dA is area of this is 4 pi A square. Right. And this radius is also A, so this will become A. So we get capital A into 4 pi AQ into epsilon naught is equal to Q. Right. So we get 4 pi epsilon naught A into AQ. Okay. This is then 38th. Special distribution of electric field with charges A, B is shown in figure. Which of the following statements is correct? So if you see here it is electric field lines are coming inside. So B is negative and A is positive. A is positive. See? A is positive, B is negative. This is wrong. So this is incorrect. And A is greater than B because here it is more crowded. Here it is only 4, here it is 6. So more crowded means more charge is there. Electric field is more. That 9th point charges plus Q minus Q plus 4Q are kept on x-axis at x equal to 0, x equal to A, x equal to 2A. So this is only minus Q is in stable equilibrium. So equilibrium wise, if you see, this will be at equilibrium. Then this will attract, this will repel. This will be KQ by R square 4A square equal to this is equal to 4Q into 4Q by I'm telling about force on this. Force on this will be K into this equal to KQ by A square actually. And this will be 4 into 4Q by 4A square. KQ by square, KQ by square. So for net force on this will also be 0, this will also be 0. But it is not stable equilibrium because if you displace it, there will be some force on that. It will just go. It will not come back to a stable position again. Like in a bowl, if you keep something stable equilibrium, because if you take it also from equilibrium position, it will come there only again. Like that, it will not happen here. Yes, all charges are in unstable. Then 40th figure, some okay, electric field. Here electric field will be less. Here also, sorry, more. Sorry, more, and here also more, and equal. Here it will be less. Option C. Okay. And 41. For distance far away from center of dipole, the change in magnetic field of magnitude of electric field with change in distance from the center of the dipole is. So it is k into 2p by r cube for axis, and for equatorial it is p by r cube. Right? So axis is more in case of axis as compared to it is d. Then this 2 charge plus q minus q are placed on x-axis separated by distance d. Where should a third charge 2q be placed that will not experience any force? We give 2q, this will repel, this will this will repel, this will attract, so this will not happen. So it should be either this side, this will attract, this will repel. Either this side or that side. So if you keep this side, just have to take some x and then find force in terms of this. The force due to this will be 3q by x square. Then due to this it will be q by d plus x whole square. Then I solve it, you will get the answer. In 43, a charge is placed at each of opposite corners of a square. Q charge here. A charge Q is kept at each of other two corners. The net force on Q is 0, then Q by Q. So on this force we will due to this repulsion. Due to this also repulsion, due to this also repulsion. If this is the case, it will not be 0, so it has to attract. This also has to attract. The net force on this side, it should be equal to this. So it should be kq by this will be root 2a square equal to due to this and this, it will be ff root 2f. So root 2 k q by due to each it will be a square, that's all. So a cancel, q by q will be 2 root 2, but they are attracting minus 2 root 2. So minus 2 root 43 is d. And 44, identify wrong statement, right? Coulomb's law correctly describes the electric force that the wrong statement is binds electrons of an atom to its nucleus, correct? So, binds the protons and neutrons in the nucleus, no. Binds atoms together to form molecules, no. Binds atoms and molecules. This is the ornament actually. You go ahead. 45th. An oil drop of radius r and density rho is held stationary, right, on a vertically upward electric field. So vertically upward electric field is there. So mg will be here. So it is held. It means it's a positive charge. So it is hitting upward direction force. So positive charge and deficiency of electrons. And how much deficiency? So Q by M is mg. So Q is N into E. Right. So this is the number of electrons. So it will be by E. M is density into volume. So density is 4 by 3 pi RQ into, sorry, volume is 4 by 3 pi RQ into density. Okay, here air is also there. So buoyant force will also be there. Buoyant force will be upwards. So it will be mg minus buoyant force. Minus will come here. So rho minus rho we will get into g. It will be mg part. And option C. Then 46th. The square side of length okay, interacting. Okay. Electric flux inside the link to the surface in units of voltmeters. So they are asking how much the flux. See, if you see flux, no, integral E dot dA is equal to Q inside by epsilon. There is no charge in the inside. So flux will be 0. ठीक है, जितना आ रहा है अंदर उतना बाहर जा रहा है actually. So that's why flux is 0. There is no Q inside. 46 is D. 47, an electric dipole moment of moment P is placed in a uniform, okay, has minimum potential. So potential energy is minus P dot T. So minimum means minus P sin theta minus P when theta is 90 degree, and it will be minimum. 47 is okay. Sorry, it is dot product. So P cos theta. So it will be minimum when it is minus P. Theta is 0 degree. You metal cos when it is 0. But 0 is not the minimum. Minus negative value is the minimum. So then we have 48, 49, 50. The charge Q in a body is always given by Q equal to N into correct. By convention, charge is electron is taken to the meter, correct. The fact that electric charge is always integral multiple is called as quantization, correct. So this should be wrong. What is experiment demonstrated Newton? Okay, I don't think it is Newton. You have to just check it. But the fact that these three are correct, this may be incorrect. And then 49th. Two parallel metal plates having charges plus Q and minus Q face each other. Okay. Plus Q minus Q. At a certain radiation, if the plates are not dipped in corrosion. So it is electric field will be. So electric field will be somewhere like sigma by 2 epsilon. But when it is dipped in dielectric, some kerosene and another emission will be dielectric constant. And it is K equal greater than 1 or equal to 1. So this is more increased. So if this is increased, this will decrease. Right? The electric field will decrease. 49 is D. 58. So actually it is in 50th I will tell you later. Some confusion here. 6 is given as answer. Okay, so we'll end here. The 50th we'll do later in the class. So any doubt you can come to me personally or in the class. So we'll end here then. This is the next.